Okay, for the last problem of the evening, I'm going to use Geogebra actually to demonstrate this. Um, so we're going to begin by plotting some points, and then we're going to subject it to two transformations. So I guess we can flip back and look at them. So let's start with these 3 points, M, J, and N. And I may use different values just for convenience, but the first point that I've got here is the point M, and it should be at 3, 3. So in Geogebra, down in my input menu, I'm just going to open up a pair of parentheses, and I just do 3 and then comma 3, and close it and press enter. So you can see it's calling it A. I think that's fine. I'm going to work with A. The next point that I'm going to have is 1, 1. So again, I open through parentheses, and I'm just hitting a 1 and then a comma 1, close the parentheses and press enter. And you can see this in the input bar below. There's point B. The last one it'll call C, but it's supposed to be at 6, 1. So open parentheses, 6, comma 1, close them, and there is point C. So I've got this beautiful little triangle. If I wish I could zoom in and look at it a little bit closer and see it a bit better. And in fact, I didn't actually make the triangle. There is a Polygon tool. If I wanted to, I could grab it. And basically, you just click the vertices that you wish. And you have to always go back to your starting point. So I just pulled this one back over in there. So now I've got this triangle now that's all super cool. But we're going to subject this thing to a couple of transformations. The first thing they do is they say we're going to take this triangle and we're going to rotate it 90 degrees counterclockwise. Ooh, about the origin. Okay, let me try this. So this could be a problem because I think I'm set up to go clockwise. So let's see. If I grab my rotation tool. So in Geogebra, this is the transformation menu, right? We can reflect about a line. We can reflect a point. These are two that we don't use much. We can rotate something about a point, and that's what we're going to use. But then there's also translation by a vector, and then we can do dilations from a point. So we're going to rotate around a point. The thing that in this order, you click what you're going to rotate, and then you click the point where you're going to rotate it about. And I just realized I made a terrible mistake. I don't have a point at the origin, so I'm going to put a point at 0, 0. Yeah, there's a point at the origin, it's point D. So let me try and rotate this again. So this point about the origin, and then Geogebra asked me what angle do you want to use. You know, I wanted to show this kind of interactively, so let me try this. I'm going to say we want to go counterclockwise, but we want to go, I'm going to make it go alpha degrees. And the reason why is I set up this slider. Alpha is currently at 0, but alpha will go from 0 to 90 for me, so I can just drag this along. So I'm going to rotate it counterclockwise by alpha degrees, so I'll hit OK. So what happens now is if I grab the slider, oops, right here, this tool, and I just slide this around, you can see this is rotating it around the origin. So my center of rotation is this point right here, and that will look different. If I was rotating around point B, totally a different beast, but I'm rotating this whole plane around point D, and you can see it goes, that's just wonderful. And then lands there, right? So that's that rotation. So the question says name the coordinates of MJN. Uh-oh, MJN. I should let me annotate this on this diagram. Another thing you can do is you can do a pen on top of it. So get back up here, Geogebra, just so we have a reference point, right? This was M, right? And then this was J, and this was N. So we have something to refer to. So the coordinates of MJN, if you look, M is this point over here, right? It's at -3, comma 3. That's where it went to. So this point, it was A, went to A prime. So M is at -3, 3. J is at -1, positive 1. And N is at 6. N prime rather. This one, N prime, it was C, is at -1, comma 6. It's kind of instructive to look at the patterns of what happens with the points. For example, if you look at C, right, C, which is N, it was at 6, comma 1, right? And notice where it goes to. It went to -1 comma 6, -1 comma 6. So I see this happening, right? X, when I'm rotating counterclockwise, right, the X just went to the Y spot, right? The 6 went to where Y is, right? It was X over here, now it's Y. And the Y goes to the X spot, but it changes its sign. So, and that actually happens for all three of those points, for M, J, and for N. In which you can see the answer for part B there, or part A. And then it finally says, next reflect this triangle, this new one, right? This one over here, across the y-axis. So in GeoGebra, I want to delete this inking here. So I've got these things called pen strokes, right? If you hit that, it just deletes them all, or shows them again. That's great. So they're all gone. But now I want to do a reflection across the y-axis. So this is a cool tool. You just come in here and you say, look, reflect about a line. I want to reflect this polygon, so I tap it, and I want to reflect it across this line, so I just tap the line. And as soon as I do that, boom, it just makes the reflection happen. It's just perfect, right there it goes. And then it says, what are the coordinates, name of the coordinates now? So you can see, interestingly enough, A, or M goes right back to where it started, right? M started out at 3, 3, and now it's back there. And B actually started at 1, 1, and it's back there too. So after those two transformations, two of the points go back to where they started. What didn't go back to where it started was C, or this was point N in the original problem, MN, the MJN. N is in a different spot. N is now at 1, 6, right? But the other two are where they were at the very, 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 very beginning. And then the last question is, what's the area of this original triangle? So that's not tough, right? Let's look at that. So the original triangle, if I zoom this in a bit, the area of a triangle is 1/2 base times height. I don't have evidence that this certainly does not look like a right angle, right? So I can't treat those as a base and a height, but I can certainly say that this is a height. And in fact, that height is, I don't have the pin, the height of that is 1, 2, 3, this is 4 units long. And then this would be the base that goes with that height, right? This base is, what is it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. So if I was to multiply, oh dear gracious, I don't know what you are. Actually, what I neglected to point out was the scale of this thing. Every two of these is just 1, right? So this is 1 unit long. So this is actually not a height of 2, it's just a height, 4 rather, it's a height of 2. And then along the bottom here, I'm going from 1 all the way to 6. That should be a length of 5. So that's 1, 2, 3, 4, 5. Yeah. So, the area of this triangle is 1/2 of the area of this rectangle. This rectangle's area is super easy to find. It's just 2 times 5, or 10. The area of the triangle then would be half of that. So remember, the area of a triangle for these reasons is always, area is 1/2 times the length of the base, which we found was 5, times the height. So 1/2 times 5 times 2, which would be, 5 times 2 is 10, so half of that is 5. And units squared, it's an area, they're not length, so units squared is the area of that triangle. And I didn't ask you to find its perimeter, did I? Nope, just the area.